So we've been working on using if statements to control how our program runs. We can say that if this happens, then do this. If this happens, then do this. We would say that an if statement is a control structure. It controls the outcome of our application. It controls our program flow. And it's not the only control structure that programming languages have. There are other control structures. If an if statement is called a conditional structure or a conditional statement, we have control structures that let us do things repeatedly. It lets us do things, we would say, in loops. And we would call those repetition structures. The one that we'll be talking about today is something called a while loop. But before we actually get into the loop, let's try and figure out what problem having a looping structure actually solves for us. I'm creating a project called while loops. And just to start, we're going to throw a button and a label on our form. Make the font size larger so that we can see what's going on. I'm going to call this one button loop. And then my label is going to be LBL message. And so this is what I want to do. I want to display a bunch of numbers, each on their own line. So I want to display the numbers 1, 2, 3, 4, and 5. And that's really not that hard, and that's something that we can do. And let's take a look and see, well, how would we do that in the first place? Well, I'm going to double click on my button here. Now if I wanted to put it all in one string and I wanted to have it all output to one label, I could do something like this. I could declare my variable. I can call it str, what did we call that? LBL message. Let's call it str message. Start it out empty. And we could do this. We could hard code this in if we wanted to. We could say 1. If I wanted it on its own line, then I would do /n. That's our escape character for a new line. And then I could go 2, 3, 4, and then if you want to put one after 5, you certainly can. And then at the end, LBL message dot text equals string message. Okay, let's run it. Now when I click loop, it's not really looping. We know it's just hard coding that in there. But each of these lines is displayed, each of these numbers is displayed on its own line. And that's great, but what if we have some sort of input from the user where the user gets to pick how high we count, right? So let's say I had an input and the user typed in 5. Then it's going to say 1, 2, 3, 4, 5. If the user typed in 6, then we want it to say 1, 2, 3, 4, 5, 6. We want it to count up for us. Well, how could we do that with the tools that we have already? Well, the first thing I need to do is I need to put a text box on here because that's going to be our user input. I'm going to copy this label. Make my font here larger. And then I'm going to call this txt, let's call it txt limit. Okay, so now we know we got to get that input from the user. I'm going to declare a double here, call it dbl limit equals 0, and then we know that we have to do a try parse to get that number out. So txt limit dot text comma out limit, double limit. Okay, well now what? We have to have some way of knowing when to stop, right? So if we ran this and we know that this is, it's already hard-coded at 1, 2, 3, 4, 5, we could test it. We could test to see how far we went. So for example, we could say if double limit equals 1, and then we could just try and account for all of them. So this one, it would just be to 1. And then we could do else if double limit equals 2. And then we could count to 1 and 2. But this quickly becomes tedious. We could use a switch statement here. That might reduce some of the tedious work that we're doing, but we know that there's only a limited amount of numbers that we can count up to. We haven't even gotten to 5 yet, and it's already filling up our code, and it's repetitious code too. That's not the kind of code that you want to write. So I could type in 1, hit enter. I could do 2. I could do 3, but it's not really counting for us. It's not anything that we're really gaining out of here. It's almost smoke and mirrors. And we could try and make this better by starting out with a base, and we could say get rid of the else's, and we could add on to it, right? So we could say if it's greater than or equal to, then we start at 1. If it's greater than equal to, then maybe we can add on to it instead, right? Because then we're kind of reusing some of our code, and then the higher we go up, the more we're adding to. But this is still not giving us anything, because we know that eventually we're going to run out of code, we're going to run out of numbers. We could go up to 20, and if the user typed in 21, it's still it doesn't help us. So unless we want to go and hard code all that stuff in there and then just hope that they don't type in some one larger number than what we've put our limit in, then we're set. But what we have in our ability, it's just we don't have what we need to be able to do this kind of thing. What we need is the ability to loop, to do something repeatedly. So with what I'm doing here, this is great for 1, but wouldn't it be great if somehow we could recreate this and do it over and over again? And that's what a looping structure is. And the best way to think of how a looping structure works, specifically a while loop, which is what we're going to be talking about today, is think of it as an if statement. In fact, it works just like an if statement, but an if statement that will run over and over again until this is false. This is very important. Think of it, again, as an if statement that runs until it's false. And that's how if statements work, right? Is that this code here will execute only if this is true. So what's that going to look like? Well, before we just switch it over, and syntactically, right, it would look something like this. Instead of the while statement, instead of if, we would say while. But there's a couple more things we need, so I'm going to put that back for now. To make a loop, to make a while statement, you need 3 things. You need a counter. This is something that tells the loop how many times it's run already. It's very important. If you don't know how many times you've already ran, then you don't know how many more you have left. Think of it as when you're counting something out, counting change, counting anything. If you lose your count, you have to start over. With a computer, then you run the risk of doing something too many times, or worse, never stopping. And you get stuck in something called an infinite loop. So we need a counter. Paired with the counter, and this goes along the same lines, is we need something called a stop condition. The stop condition lets you know, well, Okay, you've counted enough, now you need to be done. And think of it as you need to count out 10 pennies, for example. You start at 1, you keep counting. When you get to 10, you stop. That's your stop condition. If you need 10 pennies, you don't keep counting to 15 or 20. You stop at 10. That's our stop condition. This is the part of the while statement that acts just like an if statement. This is the part that we want to be true. And then lastly, we need something called an accumulator. And sometimes, and in fact most of the times, the accumulator and the counter are the same thing. And we're going to take a look at that. Now, this is what we want. We were talking about before that we want this whole thing to run as many times as the user has put in that text box. So we're going to put in, just for our own sanity here, we're going to put in a 5. But we're going to hard code this in for right now. We're not going to add the complexity of pulling it from a variable just yet. This is more of a reminder that we want to run 5 times. Okay, so this is how we do a while loop. Let's look at our ingredients here. We need a counter first. So we're going to start with that. We're going to say int counter. And here's the thing about computers and counting. Computers always count at 0. And we'll be finding more out later about why we'd want to start at 0. But for right now, we just have to all agree on that that's what we're going to do. Computers start at 0, so since we're working with computers, we're writing the code, we're going to start at 0 also. Okay, we have our counter. Now we need our stop condition. Well, we said that we wanted to run this 5 times. So this is what we say. We say while, open parentheses, and here comes our stop condition. Counter is less than 5. As long as this statement here is true, the loop is going to keep running. So it starts out at 0, 1, 2, 3, 4. When it gets to 5, this becomes false because 5 is not less than 5. 5 is equal to 5. But that makes this statement false, and then it's done. Now, just like an if statement, whatever I put in between these brackets is going to be what runs 5 times. So if this is true, this will run, and then with an if statement, it would go back and it would return right here, right? When it's done, it would resume back to the normal flow of code. But a while statement's different. A while statement is when it gets to here, it actually will go back up to the top here, and it will check this stop condition again. If it's true, then the code will run again. It'll keep going until this turns into false. Which brings us to our next component of an appropriate loop, in that we need an accumulator. Because look at what we have right now. If I have some code that's running in here, it's going to come back up to the while loop and it's going to run the test again. So we start out at 0 and it says while, and then we evaluate the statement. We say 0 is less than 5. That's true. Runs the code, goes back up to the top, while, and then again it's 0 and less than 5. 0 will never equal 5. It will never equal 1 or 2 or 3 or 4 because it's always staying the same. And so that's what our accumulator is. And I always put this right at the bottom, right before the last curly brace. You say counter equals counter plus 1. Counter equals counter plus 1. This is our accumulator. Think of it as a snowball rolling down the hill and collecting more and more snow, and it gets bigger and bigger every time. That's what this does. This will gain in value every time that this while loop is run. Now you can have more than one accumulator, and often we don't refer to the counter itself as the accumulator, although it is technically, but it's really the counter. Typically the accumulator is going to be the thing that's actually doing the work here. And what we wanted to do, if we remember, is we wanted to output all of those numbers inside of our label. And so our accumulator in this case is going to be our string message. And we have to say string message, and then we want to kind of look and see, well, what were we doing before? Well, we were doing 1, and then our carriage return, 2 carriage return, and then 3 carriage return. And we want to figure out, say, well, this is what we did if we hard coded it, but is there some way that we can get this value out and do that? And if we look at it, well, look at our counter. Our counter goes up by 1 every single time. So what we could do is we could say counter.toString and then add a carriage return to it at the very end. And this is going to be our number that goes up by 1 every time. Now, the thing that's missing is, because this is an accumulator, accumulators always add a new value to the old value. And if we do this right here, we're technically overwriting the old value every time. So we want to put in string message plus. We want to do that self-assignment. So it's going to take the old value and then it's going to add the new value to it. We want to get rid of our old code here because that's just going to kind of mess us up. So I'm going to get rid of that, and then now the only thing that's setting the value is inside of my while loop here. So I'm going to run it, and we're going to see what happens. Okay, we're going to loop, and well, something happened. First thing you'll probably notice is that everything is off by 1. And that brings us back to the whole issue of, well, computers start at 0. So our first thought is we'd probably do something like this. We'd change counter to 1, and then maybe change this to 6, right? Because we want it to go up by 1. And now it works, but we want to stay away from this. As tempting as it is to just crank it up to 1, we want to stick with this. We're going to go do a little self-discipline here. We want to keep that at 0. Because later on we're going to find out that other things used, we would say this zero-based counting. We say it's zero-based because we start at 0. So we want to stick with that, as easy as it is. So what can we do instead? Well, C# loves parentheses, and so we can do this. We can be sneaky. We can put parentheses around our counter, and as weird as that looks, I could do just that, and it's going to be fine. Because remember, the parentheses mean evaluate, right? It means take whatever's in these parentheses, and we want to evaluate it out to its base value. Here, well, we know there's counter, but we want to be sneaky. We know that everything is off by 1, so inside these parentheses, I'm going to say plus 1. And what that's going to do is, it's not the same thing as counter equals counter plus 1. This actually takes this value and assigns it back. We'd say that's self-assignment. This is temporary. It's going to say, well, what does counter plus 1 mean? It doesn't save it. It's just going to add 1 to it, and then you'll notice I'm calling a .toString right off of that. And that's because this whole value evaluates out to an integer. So now if I hit loop, I get appropriately 1, 2, 3, 4, 5. Okay, so we're feeling kind of brave. We knew that before. What we wanted was to pull that out of the text box. So what we're going to do instead is, whereas we were using a hard-coded 5 in there before, now we pulled that out of the text box. We're going to use double limit. So I'm just going to copy this, and any place I can hard-code an integer, I can use an integer variable. So now we have a dynamic loop. So it's going to take whatever's in there. In this case, if we don't do anything, it's going to leave it at 5. So really, we are doing the same thing we were doing before. Except now, if I do something like 10, I can see that it keeps going. And actually, I can resize this and pull that down. We probably want to make our form a little longer, but I can change this to be just about anything I want, and I'm not going to run out of numbers. So what is this doing? Well, it's running my loop. If I did 4, it's running my loop 4 times. The first time it adds a 1, then it adds a 2, then it adds a 3, and then it adds a 4. If I change that over, I know that this loop is going to run 8 times, because look, it does 1, 2, 3, 4, 5, 6, 7, 8. Now, it turns out that when you're doing things like this with your accumulators, and this would work anywhere, it's not just inside of a while loop, but if you're doing this self-assignment, right? Self-assignment is something like string message equals string message plus. It's taking its own value and then using it in a formula. There's a way of doing a shortcut with this. So anytime you're doing self-assignment, you can say, if I'm doing equals and then I'm doing plus, I can say string message, and instead of saying string message plus a value, I can say plus equals. And then I don't have to repeat this, and I would take this value and use it in there. So that's a shortcut for self-assignment. I can do the same thing for an integer. I can say counter plus equals 1. So that's saying take my value, add 1 to it, and then store it back in the original variable. Now, because of how we often will use counters inside of a loop and how often we'll usually add 1 to them, there's even another shortcut when you wanted to add 1. And this only works with integers. You would say counter plus plus. Doing this will add 1 to its own value and then store it away. And that, if you've known anything about programming languages, the programming language that C# is based on is called C++. Well, C++ in itself was based on C. That was one of the first languages of the whole lineage, if you will. And so when you had C and then you had C++, that was like saying that's a new version of C. So that's a bit of a programmer's joke, but now you know what that is all about. And so I will say same as. And so usually when we're using an accumulator, specifically our counter, and we're adding 1 to it every time, we'll say counter plus plus. So what would we use this for? We probably wouldn't use it to just display numbers on a form like this, especially since the output itself onto a label is really not that interesting. But what you would use this for is to loop through pieces of data. We would say that data can be put into collections or lists. So whereas you have a single variable, like a string or an integer, we have things that we would call data structures that contain a long list of data. Think of something like a phone book or an attendance list or a table of contents, right? Well, computers are able to cycle through that information and do work with it. Think of it as maybe if I had an attendance list, I could write a program that would loop through that attendance list and send all of you an email automatically. And I would keep your emails as a string in that list. And doing something in a while loop would be perfect for that, because it can do it repetitiously. It can run a different piece of code every time that it's run, and it can run the same thing every time. But we're going to work on that next time. Right now, let's get a little more comfortable with doing this loop. The first thing is that typically when you're looping through some data, you wouldn't put it in a label like this. There's a special control that works great for displaying a list of data, and that is called a listbox. And that is right underneath, should be under the all Windows forms. And we're going to say listbox, and we're going to drag it onto our form. And the naming convention for a listbox, let me make my font match up everything else. It has a font property. There we go. The naming convention for listbox is LB. I've also seen LBX, but I'm going to do LB, and we're just going to stick with our current convention. I'm going to call it LB message. Drag this out. And now what this is for is you're able to display a list of data. And if you wanted to hard code it in, we could add it through our code on our form load, but instead, if you look, there's a property called items. And if you click on where it says collection, the ellipsis button shows up. That's the button with the 3 dots. And it lets you type values in. So we could say something like 1, 2, 3, 4, 5, right? Each item goes on a new line, and it's going to display it out just like that. And so we even have a little prototype here, right? We have 5, and then look, it's displaying 1, 2, 3, 4, 5. That's hard-coded in. We might want to work with that manually, but let's see how it works first. And now you can see that I have that on there, and each row is clickable. So we could have something interesting happen off of this, depending on what number is clicked. But that's good. We did that through the designer. That's nice, but we don't want this to happen right away. In fact, we want our form to kind of be cleared out when it starts because the user might get a little confused. So let's double click on our form. First thing we should have done is clear out our message that we have. And then to clear out your listbox, listbox has that property called items. That's where we hard-coded that stuff in, right through here. Well, we can access that through code, so we're going to say lb message dot items and then dot clear, and that will delete everything that is inside of that list box. And so now we are good to go. But we want to take our label stuff that we were doing before, and we want to use that in our list box now. So let's scroll up here, and we're going to use the same thing. Whereas we were dumping things into that string before, now we're going to add that into our list box. So we say lb message. Probably should have went with a different naming convention because lbl message and lb message aren't so great. We should go back and change that. I think we'll go with lbx. I'm going to change my name here. lbx, that way we won't get confused. Okay, that changed it for us. Alright, lbx message, and we say dot items, because that's the item collection we were working with, dot add. This will add a new one into it. And now we can use, if we look right above us, we can see we have counter plus 1 dot toString. And we don't need to do the new line character because this will put it all on one line for us. We no longer need string message. I'm going to comment that out. And we no longer need to do the LBL message output. So now we have it. And the nice thing about the list box is if I went up to past what was already displayed and I said 10, it'll put a scroll bar on there for us. So now I could go to 200 if I wanted to, and my loop just ran 200 times. I can go back to do 5. Let's try 5, and oh, well, what's happening? It took all my old input and it's just tagging it on the end. So just how we clear it out when we do our form load, we also want to do a clear every time we want to add something new. We want to start over. So in the beginning of my button loop click, I'm going to say lbx message dot items dot clear. And now every time I start, it's going to let me start from scratch. Go back to 5, and now I get a fresh start. So when you want to allow the user to select something inside of your list box, we need to have some way of communicating that back out. And just like any other control that we've done in .NET so far, when you want to get to the most common event on your designer, you're going to go over the control and you're going to double click. And that will add a event for selected index changed. And what will happen is this will fire every time you pick a different index. So if I pick 1 and then I pick 1 again, it's not going to fire. But if I was picking 1 and then I changed it to 2 or changed it to 3, now it's going to fire off. So let's reuse that old label and let's display which one was picked. So I'm going to say LBL message text equals, and then here we go, LBX message dot selected index. This is the one that was picked. That's an integer, so I'm going to say toString. And now I loop, and when I go in and I pick it, now you look, it's off by 1. That's because this is zero based, like we were talking about. So we want to match our numbers up. We were going to want to do this instead. We're going to go after that integer, and we can say plus 1. Now, if this makes you uncomfortable, you can declare a temporary variable. We could say int selected index equals, and you can do one of these instead. We can split it out so that this might be a little easier to read. But we'll get the same behavior, loop, and it's going to tell me which one I am. We forgot to add 1 to it. There we go. So when you do a while loop and you want to display multiple output as a result of that loop, you would use a listbox. So that is our looping structure. Our first looping structure, we're using it to count up. It's dynamic. The user is deciding how many times the loop should run. It's counting up starting from 1. And we know that behind the scenes it's starting at 0, but from the output it counts up to 1, 2, 3, 4, and 5, or whatever they're counting at. We know that to make a correct looping structure, in this case a while statement, we need a counter, we need a stop condition so we know when to stop, and then we need an accumulator, which does the work, and it also keeps us from coming into an infinite loop. Now, some of you that are following along may have forgotten to do the counter on there. So watch what will happen when we do our loop. You can hit loop, and it's not going to burn your computer up, nothing's going to start on fire, nothing's going to crash. However, you're going to notice that, and if you're lucky, you'll get the not responding. You won't always get that up there. But you will notice that the application is it's not responding anymore. You can't close it down this way. If you're lucky, you'll get this. Most likely what you're going to have to do after you hit loop is you have to go into Visual Studio and then go to debug and stop debugging, because Windows won't always let you get a hold of that application to close it down. So we need this in here, and this tells us when to stop. Otherwise, it's going to run, and it's going to run a lot of times, because this is something that your computer can do very quickly and can do a lot of times as well. So we can see that this is powerful, and it gives us the ability to do some things that we really couldn't do with just if statements. And that always centers around repetition. And this is something that's very good for it. Later, we'll be learning how to use this to loop through lists of data, through collections of data, and we can start seeing how powerful this can really be for us.